So in this video, I want to talk about resonance. And resonance is a really important concept to understand for orgo because you'll be using it throughout the rest of your studies with organic chemistry. So resonance is a method to show true electron distribution of a molecule. And so it's essentially a hybrid. And so let's do an example. So you have this. With a negative charge on the oxygen. And so as you can see, these oxygens don't look like they're equivalent drawn like this. However, when you do an experiment, you actually find out that those two oxygens are actually equivalent when you experiment on them. So this needs an explanation. And so this molecule actually looks something like this, a hybrid. So it will look something like this. C O O, and then now I'm going to use a dashed line to represent the electron distribution. And so you'll have 2 electrons there, 2 electrons there. And so what you end up with is a partial 1/2, negative 1/2 on each of those oxygens. And so there are the 2 structures that this molecule could resonate between. And I'll draw the other one down here. That's a negative. And then so that resonance arrow indicates that these 2 molecules are resonance structures of each other. But what the actual molecule, what it actually really looks like is that. And so there are some important resonance rules to draw resonance structures. And so you can never move atoms. So one arrangement of atoms is the same. Meaning if you have a carbon and an oxygen there, for example, I won't draw out the hydrogens, you can't move this oxygen like this and this, for example. Let's pretend that's an oxygen. These would not be resonance structures. And so you never break bonds, and you only move you only move lone pair electrons. Or pi bonds, which means double / triple bonds. And some other important things are you want to satisfy the octet rule, which means that all atoms have 8 electrons in their orbit. And then ideally you want to put the negative charge on the most electronegative atom. And so, for example, if you have the option of putting a negative charge on a carbon versus a bromine, for example, you definitely want to put a fluorine, sorry, you definitely want to put the negative charge on fluorine. And one final thing to note is all resonance structures contribute to the overall structure, but the lowest energy / most stable contributes the most. To the resonance structure. And so let's do a few problems, practice problems now. I'll make another video for more practice problems. But for example, let's say you have some molecule A, B, C. Just doesn't really represent anything. You have a negative charge there. And so this could actually be in resonance, remember resonance arrow right here, with this. A double bond B, C. And so you might be wondering how that happened. Well, the electrons here moved to form a double bond there, and then since B doesn't want 4 double bonds to it, one of the bonds from there, the double bond, moves to C, and so you result with that structure. And then you could also have something like this, where you have a positive charge on A going to B, going to C, resonating with this. And so, as you can imagine, this double bond here just moves there. And I'll give more examples and practice problems of resonance in a future video.